Welcome to Elementary Functions. Today we're going to talk about the dot product. My name is Wendy Fresh. I'm from Portland Community College and this is Math 112. First, let's talk about understanding the significance of the dot product. And we'll begin with the definition. If vector v is equal to a sub 1i plus b sub 1j and vector w is equal to a sub 2i plus b sub 2j, and both of these are vectors, then the dot product indicated with vector v with a dot in between it, vector w, is defined as a sub 1 times a sub 2 plus b sub 1 times b sub 2. And the result is what we call a scalar. In other words, it should end up being just a number. So let's take a look at an example. Find the dot product of the two vectors if vector v is 2i plus 5j and vector w is negative 3i plus 8j. So for the first one, finding the dot product of v and w, we will take the a value of 2 and the a sub 2 value of negative 3, and we'll multiply them and add them to the b value of 5 and multiply it by the b sub 2 value of 8. And that gives me negative 6 plus 40 for a dot product of the scalar 34. Now we're going to find the dot product of the vector v with itself. And so what we're going to do is take 2 and multiply it by itself, and then add that to 5, also multiplied by itself. I suppose another way that I could have written that would be 2 squared plus 5 squared, or 4 plus 25, which is 29. Also a scalar. Some of the properties of the dot product are proved in your textbook. For now, we will just focus on using them. We'll begin with the properties of the dot product theorem. It says if u, v, and w are vectors, then for the commutative property, we know that the dot product of u and v is the same thing as the dot product of v and u. And for the distributive property, vector u dot product with vector v plus vector w is going to be the same thing as the dot product of u and v added to the dot product of u and w. Number 3, if we take a vector and we dot product it with itself, what we saw in the previous slide is that we ended up with a squared plus b squared. And if you recall, let me just put this off to the side, just recall that in the last section we said that the magnitude of a vector is equal to the square root of a squared plus b squared. So if I square both sides, I think I get an expression for a squared plus b squared, which is what I have on this second line. So another way of writing a squared plus b squared would be to say the magnitude of a vector squared. Number 4, the dot product of a vector with 0 is 0. And number 5, the dot product of u and v, another way of expressing this would be the magnitude of vector u and the magnitude of vector v multiplied by the cosine of theta, where theta is the angle between the two vectors. Now, this proof is in your textbook. It comes from the law of cosines. I'd like you to take a look at it, but for now we're going to focus on using this and see what we can come up with.